All right, team, in this video, we are going to be simplifying square roots, but what's different? Hopefully you said, hey, there's a variable there. Okay, two different ways to do this, but it's going to piggyback off of the ways we've already met, or we've already known, or learned. So let's start with the factor tree method. The factor tree method, we can break down 25 into 5 times 5. Oh, I bet 25 was already a perfect square, right? Because remember, when the two numbers end up next to each other, whatever you just broke down must have been a perfect square. Okay, so we've got a pair of 5s. One of them is going to come out. But what do we do with the variables? X to the 6th is the same as saying x times x times x times x times x times x 6 times. 1, 2, 3, 4, 5, 6. Okay. Same thing though, take out pairs. So we have a pair there, and a pair there. How many total pairs do we have? 3. So the square root of x to the 6th is x to the 3rd. Essentially, you're asking yourself, how many pairs are in x to the 6th? The easiest way to find out how many pairs are in something are to just divide that number by 2. Okay, that one wasn't so bad, but let's take a look at another problem. And let's change it. Here we go. Let's change it to, I do want to come back to that one. Here we go. Let's change it to where the exponent is odd, because if the exponent is odd, you won't be able to take out an exact number of pairs. You're going to have one left over. So let's talk about this one. Let's try the factor tree. Break down 13. Oh, 13 doesn't really break down because it's already prime. 13 times 1, right? So that's not going to work out. We'll leave it. So nothing is going to change with the number. So I already know it can't be that or anything that is a 13 on the outside. Nope. So the 13 is going to be staying. But x to the 9th, 6, 7, 8, 9. We can write out 9 times. There are 1, 2, 3, 4 pairs. So this is going to become x to the 4th comes outside because we're taking the square root by deconstructing this with pairs. Inside we'll have a 13 and this lone x. And that is answer choice D. Many students don't like the idea of writing all these x's out. So what could you do? Think about that for a minute. What could you do if you don't want to write those out? Okay, I got it. Yeah, hopefully you got it. Just think to yourself how many pairs. If the exponent is even, like it was in the previous problem, you will be able to remove an exact amount of pairs and then have no x's on the inside. But when it is odd, like in this problem, you will be able to remove some pairs and then you'll have to leave one on the inside. Okay? So just to clarify that one thing, if this said 13x to the 8th versus if this said 13x to the 9th, what's it going to look like? Let's see. If it's x to the 8th, I know there are 4 pairs in 8. So I'm going to be taking out an x to the 4th, and that's my final answer. However, if the exponent is 9, I know that we're not going to have an even number of pairs. So I have to think, how many pairs are in 9? Drop it down to 8 so you can figure out that there are 4 pairs in 9. But remember that there's going to be 1 left over. So anytime the exponent is even, you will see just variables on the outside. And if the exponent is odd, you'll see them on the inside and outside. There's always going to be that 1 left over. Okay. When in doubt, you just write the variable out as many times as you see it. And you just circle the pairs to actually count. And if you if you circle and you have one left over, that means there's going to be one on the inside. All right, I hope that helps you for expressing radicals in simplest form when there is a variable present.